I'm going to take scrap metal engineering and I'm going to build a wheel balancer for this 18-inch disc. Hi, my name's Dale, and welcome back to Metal Tips and Tricks. You know, this is going to be a fun video. I want to show you how to make a wheel balancer. Now, if you watched part 1 and part 2, I showed you how to turn down a disc and deal with harmonic balance problems. Now, we have to make sure that this thing's going to rotate smoothly at 1700 RPMs. And I don't have what you would call a wheel balancer because I don't have to do things like this very often. But with just some simple items that I already have in my shop, I'm going to show you how to make a wheel balancer. And it starts out with the components I have here. Things we're going to need a level. Even though this one's a little shoddy looking, it'll still work well. I need some shim material. Here's some of our heroes right here is some just drill rod. This here looks to be about 1/4-inch drill rod. Some tape, a large aluminum block, steel block, wood block, you'll see what I mean later, a clamp, and then the foundation are these aluminum rails. Now, one thing about aluminum extrusions, they are flat. They're amazingly flat and will work great for what we're going to do here. And what we're going to do is we're going to extend this out, tape these rails down, get it all level, and then put the disc on it. So the aluminum block we're going to clamp down to the table now. This is wide enough to give me the set of rails clamped in between it so this fits, just barely. Now I'm not going to give you measurements on this stuff because this is kind of a scrap metal engineering project. Bring this out. We know we need to have, let's see, at least 18 inches. Now the reason I need that much is enough for the wheel to roll. So technically I only need 9 inches, but you have to have it roll. So we're going to clamp this aluminum block down, and it's going to become our foundation. So I'm bringing the block back just a little bit, and the reason I'm doing that is if I need to put some shims under here, I want to be able to do that fairly easily, and I don't want the block in the way. I also know that I want to have these two ends at the same distance because as I lift them up, if I lift them up equally, they'll rise equally. If one's back here and I lift it up in this one, the heights will be different. So we need one more clamp actually. Come in here with a level. Actually, we're good on that one. That one's a little off. Oh, no, that one's off. So I'm going to put both shims under here. Now I'm going to have these up just a little bit because I think the weight of the wheel, yeah, it's going to press it down a bit. So we've got that set up. Now the magic is we're going to tape these down. And these are just 1/4-inch ground drill rod. They're not perfect, but they're going to be good enough. One of the things I've learned about static balance is it really matters on the size of the object you're balancing. This is a very large object, so it has the potential to overcome any of the flaws that are in these rods. If we were trying to balance a really small surface, let's say 4 inches, what I'm doing here probably wouldn't work. I'm not saying don't try it. I'm just saying that you may have to be a little more diligent, a little more careful to try to get it to work. I'm going to check one more thing here. Good. And let's see how the wheel works out. I have left this all set together just the way I had it on the lathe. And what we want to be aware of is that this is a tapered arbor, so it's going to be off a little bit, and we just have to be fine with that. So what I'm going to do is just let it set there, rotate a little bit, and see what happens. Starting to show that we possibly have a heavy spot. A lot of you may think, well, this isn't working. So if we just take this little set screw here and screw it in here, you're going to see that just a little weight of that is going to throw it off balance. And we want to check it at different points. And what we end up doing is, when this settles out, we'll mark it. And as I mark it, if I find a spot that's consistent, I know that that's a heavy side. And you have the choice of either marking on the top, which would mean that's light, or mark it on the bottom, which is heavy. You have to go with what you're comfortable with. If this is not perfectly level, this will just keep rolling to one end, okay, or the other end. You always want to be with it, so you can see that we definitely are developing a heavy spot somewhere because it rolled up, and now it's rolling back. And this is kind of like watching paint dry. So we know there's a series of holes right here that this has already been counterbalanced once. It stopped here, probably at 5 o'clock, stopped at 1 o'clock, and if it comes back up here, the balance point is probably right in between those two. So I'm going to set this right in the middle and just let go of these two lines and see where it starts to favor. You would think if you had a large aluminum disc like this, turn it down, it would automatically be balanced. Well, you have to remember that we have other things here. We have set screws. We have different length screws holding it together. Those all can cause the machine to be off balance. So that's what we're balancing for. We're not necessarily balancing the plate. We're balancing the whole system. So now the question is, how do we determine how much weight to take off? Well, what we're going to do is add weight to the light side. In this case, just a piece of tape. And let's see if that changes it. There we go. So now we know how much weight we have to take off. It's about this glob of tape. Now, I don't think that is going to affect the entire sanding machine, because when I had it on the lathe, when it was out of balance, just sitting between the centers, it would fall to the heavy side. Well, when I took it, before I took it off the lathe and already had turned it down, I checked to see if I could find a heavy side, and I couldn't. So what I'm going to classify this as done. Whoa! Stop the video! I forgot to talk about one of the most important things about balancing the wheel, and that is actually removing the material on the wheel to help balance it because it's too heavy on one side. Remember how I used the tape to help locate where the wheel was actually too light? And I did it on the static balancer, and I would still do this all on the static balance system that I built, but I'd already taken apart and put it away before I forgot to add this to the video. So I'm just going to show it to you on the sander. It should be on the static balancer, so remember that. So we know where the tape is. Logic would say 180 degrees to the other side would actually be where it's heavy and we need to remove the material. So now what I would do is just take a 1/4 inch drill bit, drill in part of the way, and test it back and forth. Now, if you were really, how do I want to say, a stickler or really detailed, what you could do is get a beam scale, put the tape on one side, save the shavings as you drill the hole, put them on the other side, and see how it balances out. Now for me, I think that's a little overkill. I would just drill in and drill in a little bit further until I think I've removed enough material. Now, this wheel was balanced once, and you can see by this series of holes, the person drilled all the way through. So if I were to drill in, I wouldn't go all the way through because the sandpaper here is going to probably wear out quicker where these holes are than any other place on the disc. So I would just bring it through a little bit, see how it does, balance it out, and then if I got in, over half the way, I would start drilling a little bit on each side of that and keep working it until I got it just right. Let's get back to the rest of the video. So what I'm going to classify this as done. I think it'll be close enough for this machine because I'm sure I will plug up sandpaper more on one side than the other. So where we're at, I think we got a thumbs up. Now let's put it on the disc sander and see if I'm right. I bet you didn't expect that, did you? I've built this disc sander so it can be moved around the shop. The base of it is a plow disc. The rest of it is just kind of pieces and parts. Again, it's that scrap metal engineering. It's what I had laying around. The only thing that would have been something I didn't make was the hub to the disc, but even that, there's an inner hub that I set up so it would fit onto this shaft. So I'm going to put the disc on and let's see what happens. Well, what do you think? Face shield? I think it's a good idea. Now what I'm going to do is I'm just going to pump it on really quick. The biggest problem with the vibrations is when it was running slow. So let's find out. That's less. Well, I think that makes it a success. It's out about 2-3 thousandths. One thing is I didn't show you is I dropped this disc after all this work. So there's a big dent in it here I'm going to have to file out. It may cause me some problems, but I doubt it. So I hope you guys enjoyed this video. Remember, there's 3 parts. There's part 1 where I took the gap out of the bed, fit the disc to it. Number 2 was setting up the back, trimming that down and getting rid of harmonic vibrations. And the 3rd one, of course, is doing a static balance on this wheel. So I hope you guys enjoyed this video. If you did, give me some thumbs up. Also leave your positive, supportive comments and even your criticism done in a positive way. Until next time, go out in your shop, build something cool. Thanks. Harmonic chattering is a problem we deal with, especially on a large disc like this. Today, I want to show you some ways to eliminate that problem. Welcome back to Metal Tips and Tricks. My name's Dale. Now, I got really beat up last time for not wearing eye protection, and I want you guys to know that I almost wear this 90% of the time in the shop. The only time I don't wear it is actually when I'm doing videos. And like I've said before, the most dangerous thing I can do in this entire shop is actually do videos and set up cameras and have to dance around them. And I gotta say, it's a real headache. So when you see me not wearing this, it's not because I don't want to, it's that it's very inconvenient wearing this and actually talk to you guys, because I always have to talk through it. And I hate having to lift it up, take it down, lift it up, take it down during a video. So let's get back to this. Harmonic chattering is something we have to deal with, especially on a disc of this size. I've had it on even smaller discs, and we have to deal with it differently, mattering on the size of the disc, because the harmonics can change quite a bit. Now, a lot of you wrote in and talked about, wrapping a leather belt around it, doing different things in that fashion, talked about putting rubber mats on the back of this, trying whatever you can to absorb it. Another one I liked was using electrician's tape and wrapping around the edge to help absorb the vibration. Well, remember, everything has its place, and some work better than others. And it also matters on what size of disc you're turning. So you have to think about this. If you've got a little small bell and you ring it, you can grab it with your hands and stop the ringing. You get a big bell and try to ring it and grab it with your hands, well, you'll find out it's going to chatter your teeth before you stop it ringing. That's the same situation here, where electrician's tape, even a skateboard wheel, which is actually one of my favorites to do, is to go in with a skateboard wheel against the back side, see if you can absorb the vibration, a wood block. I tried everything on this to stop that harmonics from happening. Well, different techniques work better at different diameters. In this case, all those techniques didn't work. They weren't enough. So what I ended up doing was cutting out a piece of Millimene 3/4 inch particle board, cutting it down on the bandsaw, and then using double stick tape to stick it down. Now, if you'll notice, when I lay the double stick tape down, I laid it in random patterns, and the reason you do that is you don't want any harmonics to develop because of your taping pattern. Let's see how well we did going through all these steps. The finish is a lot better now. As you can hear, it's really heavy on one side and no cutting on the other. That's why we're doing the back side, and we're going to hope that it's going to balance the wheel enough. Now, right now I've got a cutter on here, 1/16 of an inch radius, and I'm trying again different cutters. I was able to kind of use a sharp point before to cut through. Now I'm going with something that has a lot more surface, and what I'm hoping is with a lot more surface cutting and that radius, that it helps throw off the harmonics. Because another thing that will happen in harmonics is you develop a washboard pattern. And not only is it a washboard pattern, but it's off frequency because of the radius. So every time you cut into it, it can cause more vibration. So you got to watch out for that. One of the things I did with my other cutter was, imagine if this is the surface and these are the harmonic vibrations or the chatter marks in the disc. What I did is I went in with a very slight angle to the tip. So I would cut a little into this one, a little more into this one, and a little more into this one. So what I was hoping, by hitting 3 harmonic surfaces at the same time, they would cancel each other out. Another way of looking at that is, sometimes you'll see a machine like a Rockwell Unisaw, and the motor to the arbor, there's actually 3 belts on that. And a lot of people think that's to add more friction. Well, actually, 3 belts cancel out the vibration to each other. If one starts to vibrate, the other ones cancel it out. Or if 2 start to vibrate, the third one cancels it out. Well, that's what I was trying to do there. And it worked out fairly well, best I could expect. Now I'm trying something a little different here, because I don't have that ringing, this disc bows out a little bit. So I'm going to probably stair step as I cut, just to save material and also to save time, because I don't need this flat across the back. I just need to have it good enough. I'm going to try an insert again, and this has a really sharp edge on it. This is what I was using before. I think it was just causing me way too much surface. It just caused me more vibration. So I'm going to go in with a slight radius on this. I like this because I'm actually able to hold it better in the holder. I think we're finding the magic formula. A sharper edge or a smaller radius seems to be cutting this really well. The other problem is, because the disc isn't the same thickness, is it's coming around and only cutting on part of it, but we're starting to get through that pretty quick. And like I said, I'm going to probably stair step this so I'm not taking off too much. I want to keep as much mass on this disc as I can. So let's keep cutting. Oh, one more thing is, right now I'm feeding it by hand, because if it starts to chatter, I can back it off a little bit. I'm hoping to go over to the auto feed here in a little bit and just see if I can't tweak it in. I'll say, to get the rest of this surface down at the rate that I'm going, I've got probably a good 2 hours of just resurfacing this, and I'm not going to punish you guys with the whole thing. I'll fast forward through it. There we are, all finished up. I think it's amazing, the new finish that I got. Went a lot faster than I also expected. I'm not exactly in love with the stair steps, but it saved material and saved me a lot of time. At the very end, I actually changed cutters. I went back to that original one to do the last bit. I also brought the RPMs up from 90 up to 430 RPMs. And that also cleaned it up quite a bit. It was interesting is, at that speed, this being out of balance, the machine was moving a little bit, but it didn't affect the finish. And the final quality of it, I think, is really well, and I don't have to hold any particular accuracies. Now I'm going to break this all apart, and we're going to... It's time to put the gap back in. Now, a lot of people have had concerns that this doesn't go in very well. I don't know, I've never done it before, but one thing I do know is this has never been taken out before. And the real key here, in my opinion, is cleanliness. You're going to want to come in here and make sure this is as clean as it can physically get. Because if there's one little particle off, it's going to raise it up 1/1000 of an inch, and you're going to see it. Now, this has been scraped at the factory, if you want to call that scraping. Scraping, they talk about points in scraping, where 20 points is a really good bearing surface. 40 points is an excellent bearing surface and very rarely done because it takes so much time. Well, this one here looks more like 3, maybe 4 points per square inch. So it's not that good. And what I did to clean this, I went in with paint thinner. I have a spray bottle of it, sprayed it down, went in some different brushes like this. Also, I had a little paint scraper to just kind of work everything. Because remember, this originally was painted in place, actually bondoed into place and then painted. So there was a little area here that you could see where the Bondo was sticking up, and we want to get rid of that. What you want to be cognizant of is any sort of burrs. So this is when you want to come in with a stone and just kind of check for any high spots and any edges that may be raised up. This one here you'll have some concerns because if you put this down, you'll see I'm just kind of sensing it. I'll feel if it grabs, this will rotate or stop or hang up in some way. And since this has been taken off and put someplace else, well, it could have gotten a ding someplace. And just like if you're working on the surface grinder, we're going to feel for any dirt. Actually, I should be feeling for dirt on this one first, because anything may fall down there. Now, if I had a parts washer, I'd actually take this and run it through there, because I know I'm going to have grit coming out of here in the different holes, but we're going to take a risk. I figure no matter what I do, it's going to be better than what they did at the factory. Let me check the surface. This is a contact surface here on this side. So now I have to go through, check it again. Going to put the screws in now. Tightening these screws down, in my opinion, is just like tightening down a head on an engine. You don't want to torque one down and then go torque the rest. You want to work it in place. I didn't put any sort of oil in there to help it from, what do I want to say, and any anti-seize materials, because I don't know how flat this is going to sit. And based on when I took it off, how much oil was in there, I think a lot will work its way in. It'll work through these bolts here. It'll also just, when it comes into this edge here, it'll just suck in through capillary action. So it needs to be lowered. Actually, it needs to, well, let's just lower it down on this corner and see what happens. See if that doesn't. Oh, that's pretty good. Let's try this one. Oh, excellent. Check again. That one's perfect. This one's hanging up just a hair. Nice. So take your time during this process. Still excellent. Oh, that's really good. We're going to go for a final tighten. Oh, that's perfect. Okay, let's bring the carriage over. Great. I think we have a very successful install of the Gap. I hope you guys have enjoyed this video. If you did, give me some thumbs up. Also, give me your positive, supportive comments and your criticism in a positive way. All right, until next time, go out in your shop and build something cool. Thanks.